All right, guys, so we are reviewing for the Unit 6 test, which is going to be on Thursday. It's a short day. You're only going to have about an hour and 5 minutes to take the test. So it'd be a good idea to get through this video, try these problems with me, also try these problems on your own, go over them a couple of times, make sure that you're ready for that test. So number one, now they're not going to be in the same order, but the questions are going to look similar. But this one says that NRFT is similar to GZPD. So if that is true, if these are similar shapes, angle N is congruent to what angle? And remember, for this one, you just find the letter that's in the same place as the N, which would be angle G. So there you go. There's a freebie for you. In fact, there's a lot of those on this test. I think there's a lot of these questions that realistically, as long as you've seen them and practiced them a little bit, they should be relatively simple for you. So number two wants you to solve the proportion. In order to do this, we have to cross multiply. So I take this 4 and multiply it by the b minus 3. And I take this 12 and I'm going to multiply it by 2b minus 2. And then I distribute. So 4b minus 12 is equal to 24b minus 24. Be careful of these negative signs when you distribute. Now we'll minus 4b from both sides. So negative 12 is equal to 20b minus 24. You add 24 to both sides. So positive 12, because it's negative 12 plus 24 equals 20b. And then you're going to divide by 20. Now, here's where we need to be careful, because my answer comes out 12 over 20 is equal to b. But it wants me to type an integer or a simplified fraction. This is not simplified. It reduces to 3/5. So make sure you understand what kind of answer you're typing in, because this test, they're all different. Some of them want you to round to 1 decimal. Some of them want you to round to a whole number or simplify a fraction. You've got to be really careful about those. All right, number 3. The figures shown are similar. Find the lengths of x, y, and z. So this big shape and this small one, these quadrilaterals, are similar. So whatever I have to do to go from 28 to 14, I do the same thing to go from 56 to y, and 51 to x, and 51 to z. So first of all, I need to figure out, how do I go from 28 to 14? So remember, you take the new shape. We're looking for a scale factor. And my scale factor is the length of the new shape. And we're going to call this the new. And this is the old, because I know all of these values. So the scale factor is the new over the old. And in this case, my new is 14 and my old is 28, which means my scale factor is 1/2. So to go from this value to this value, I have to multiply by 1/2, which in our case, in this problem, that's the same as dividing by 2, but it won't always work out that way. Our numbers are just nice in this example. So to go from 51 to x, I have to do 51 multiplied by 1/2, which becomes 25.5. And it says to write as a decimal or an integer. Well, that's a nice decimal. There's no rounding needed. To go to y, I have to go from 56 to y. So I have to do 56 times 1/2, which is just 28. And to go to z, I go from 51 to z. So again, I do 51 times 1/2, which is 25.5. This problem was nice because it's a 1/2. It's not always or not guaranteed to be a nice 1/2. You might end up with something like 3/4 or 2/3 or some other fraction. So make sure you set it up as new over old. Okay, number 4. The blue figure is a dilation of the black figure. So I started with the black. The dilation means it changed from the black to the blue. So in this case, it got larger. It was an enlargement. Obviously, the blue one is bigger than the black one. And it wants me to find the scale factor, which again, remember, scale, you take the new image and divide it by the old. So looking at my picture, I want to look at a side that is easy to measure. And I'm going to use this left-hand side right here. So I want my new shape first, which is 1, 2, 3, 4. So my 4 goes on top. And then my old shape, that same part, is 1, 2, 3. So 4/3 is simplified like it wants. And that would be my scale factor. That means I take my old shape, multiply everything by 4/3 to get the big blue shape. All right, number 5. A dilation has center 0, 0. Find the image of point L, which is at -8, 0 for the scale factor 4. So I have this point, -8, 0, and it wants me to scale it, to dilate it, with a factor of 4, which is easy because I just multiply everything by 4. So -8 times 4 becomes -32. That'll be my new point. And 0 times 4 is still 0. And it wants us to type it as an ordered pair. So -32, 0 would be my L prime point, my dilated point. So you take the values of our point, multiply it by the scale factor. And again, this could have been a dilation of 1/2, and you would have had to multiply everything by 1/2. But in this case, we dilated with a factor of 4. Okay, number 6. A dilation maps RST onto R prime, S prime, T prime. Find the missing values. So I go from, in my original RS, it's 4 inches long. To go from there to my new shape, which is now 28, I need to figure out how do I go from 4 to 28, which these numbers are nice. I just multiply by 7, which means to go from 6 to this new part, I also multiply by 7. So 6 times 7, that's just 42. And to go from 5 to the new RT, I also multiply by 7. If these aren't nice numbers, again, I just take the new number, 28, and divide it by the old number, 4, and that just gives me 7. So if you can't tell how to do that, remember, find the scale factor, which is the new divided by the old. Okay, number 7, we're almost halfway through the test. Use the given right triangle to find the ratios in reduced form. That reduced form is important. It wants simplest form for sine of A, cosine of A, tangent of A. So we're using angle A right here. And if I'm using angle A, that makes 20, this side is my opposite side. The 21 is my adjacent side, and the 29 is my hypotenuse. So to write my ratios, sine of A, remember sine equaled, let's write it out. Sine equals opposite over hypotenuse. So sine of A is the opposite 20 divided by the hypotenuse 29. Remember cosine, SOHCAHTOA, is adjacent over hypotenuse. So my adjacent is 21. My hypotenuse is 29. And then my tangent of A is opposite over adjacent. So 20 over 21. And none of these simplify. Nothing goes into 20 and 29. Nothing goes into 21 and 29. So these are already in reduced form. Okay, number 8. These next two are probably the ones that, well, you have to actually problem solve and think about it a little bit. It gives me two sides of a triangle and wants me to find a lot of different things. The first thing it wants me to find is angle A, this one right here. So if I'm looking at angle A, I know this side, which is the opposite side, and I know this side, which is adjacent to it, which makes C my hypotenuse. So I can use my sine, cosine, tangent. Remember, SOHCAHTOA. I can use sine, cosine, tangent to figure out this angle right here. I know the opposite and adjacent, which is tangent. So we're going to say the tangent of angle A, because I don't know what angle A is. Tangent of A equals the opposite side, 11.6, divided by the adjacent side, 5.7. But I want to figure out A. I need to get A by itself. So I've got to get rid of the tangent. And remember, to do that, you take the inverse tangent and those cancel out, and all you're left with is A. But if I do that on the left, I have to also inverse tangent everything on the right. So in my calculator, instead of using tangent, I'm going to do second tangent so I get the inverse. And we're going to do 11 point, oh, I forgot the problem already. 11.6 divided by 5.7 goes on the inside of the tangent inverse. So my answer is 63.8314. So this is 63.8314, but it wants me to round to one decimal. So 63.8 is what I'm going to round to. And now it wants me to find angle B. The nice thing about finding angle B is I know that angle A is 63.8. I know that angle C is 90. And I know that the angles all have to add up to 180 degrees. So all I need to know is, what does this angle have to be to add up to 180? So I take 180 minus 90 minus 63.8. And I get what? 26.2 degrees would be my angle B. Because when I add those all together, they're going to add up to 180 degrees. Now it wants me to find length C. I have to figure out a lot of things in this problem. So I know this side of the triangle. I know this side of the triangle. I'm just looking for the third side, which is my hypotenuse. So I'm going to use A squared plus B squared equals C squared. And remember, C squared is the hypotenuse. So A we'll call 5.7. 5.7 squared plus B squared, 11.6 squared, is equal to C squared. So let's plug at least part of that in. 5.7 squared plus 11.6 squared comes out to 167.05. So 167.05 equals C squared. It doesn't equal C yet. It equals C squared. So to figure out C, I have to square root both sides. So I'm going to go back to my calculator. I'm going to take the square root of 167.05. And when I hit enter, I'm going to get 12.924. So that equals 12.924, and it wants me to round to one decimal. So I'm going to round this to 12.9. Okay, number 9 is similar. It gives you parts of the triangle and wants you to figure out the rest. So it tells me that this is 26 degrees. This one is 90 degrees. And now it wants me to find the measure of angle B. Well, that's easy because I know they add up to 180, which means if I take away 90, I'm left with 90 degrees. And if I take away the 26, I'm left with 64 degrees. So that means this angle up here is 64 degrees. Okay. Now it wants me to figure out A and C. It gives me one of the sides, this one right here, and it wants me to find length A, this one. Now I'm going to use the angle that it already gave me to begin with. I kind of try to do that as a habit, just in case maybe I got this angle wrong. So if I use the angle they gave me, this 26 degrees, then this side A that I'm looking for is my opposite side. The 19 is my adjacent, and my C up here is my hypotenuse. So I know the adjacent. I'm looking for the opposite. So opposite and adjacent, remember, again, SOHCAHTOA. Opposite and adjacent go with tangent. So I want the tangent of angle A, which is 26 degrees. So tangent 26 is equal to opposite A over 19. And to get rid of the dividing by 19, I'm going to multiply both sides by 19. So my answer is going to be tangent 26 multiplied by 19, and that's going to equal A. Now, I want to be careful. When I put in tangent, whoops, not second. Stop it. When I put in tangent of 26, I need to make sure to close that parenthesis. Okay, I'm multiplying by 19, but I want the 19 on the outside of the parentheses. So tangent 26 times 19 is 9.266. So that equals 9.266. Round to 1 decimal place, so I'm going to round this up to 9.3. So this side right here becomes 9.3, which is reasonable. As far as finding length C, in this case, I don't want to do a squared b squared equals c squared because 9.3 I rounded, so it's not an exact answer. So instead, I'm going to keep using my sine, cosine, tangent. Now I'm looking at the hypotenuse, and I'm going to still use my adjacent because I know this is exactly 19. I don't want to use my rounded number. So we're going to use the adjacent and the hypotenuse, which go with cosine. So the cosine of 26 is equal to my adjacent side, 19, divided by the hypotenuse, which is c. And to get c by itself, first I have to multiply both sides by c. So c times cosine 26 equals 19. To get rid of that cosine 26, I can't just divide by 26, guys, because cosine is not being multiplied by 26. Cosine 26 is its own number. So I have to divide by cosine of 26 and divide by cosine of 26. So then this cancels, and I'm left with c equals 19 divided by the cosine of 26, which we're going to go 19 divided by cosine 26. Enter 21.13. So that becomes 21.13, and it wants me to round to 1 decimal place. So 21.1. Now, if you had done this, the a squared b squared equals c squared, and rounded, you would have ended up with 21.2, which means you would have got the problem wrong. So don't use a squared and b squared when you're using a number like that one that we rounded. Okay, let's move on to number 10. Story problem. Nice thing is it gives you the picture. So you don't even have to come up with what it might look like. It gives me an angle of 70 degrees. That's the angle of the sun. And to the nearest foot, it wants me to figure out the height of the tree. So if I'm looking at this 70-degree angle, the height of the tree is the opposite side. And the 32 feet that I know is the adjacent side. This side here, the hypotenuse, I don't really care about it because I don't know anything about the hypotenuse. And I'm not trying to find it. I'm just looking for the height of the tree. So when I look at my SOHCAHTOA, I have opposite and adjacent, which go with tangent. So the tangent of 70 degrees, because that's the angle I'm using, is equal to the opposite h divided by the adjacent 32. And to get rid of the 32, we're going to multiply both sides by 32. So my height, now this h doesn't represent hypotenuse. Remember, this h is my height. My height is 32 times the tangent of 70. So we're going to do 32 times the tangent of 70. Close that parenthesis, and I get 87.91. And it wants me to round to the nearest whole number. So 87.9 is going to round up to 88 feet. And you're done. Okay, number 11. Similar problem. It gives me a story. A tower is 119 feet tall, and it casts a 162-foot shadow. And it wants me this time to find the angle A. So looking at my picture, I know the opposite side, and I know the 162, which is adjacent. So again, SOHCAHTOA. I'm using opposite and adjacent, so I want tangent. So the tangent of this angle that I'm looking for is equal to the opposite 119 divided by the adjacent 162. I want to get rid of the tangent in front of the A, so I can't divide by tangent. I have to do inverse tangent to make it go away. So I do inverse tangent on the other side as well. So 119 over 162. So we're going to do second tangent to get the inverse. 119 divided by 162. And that gives me 36.29. So that equals 36.29. And it wants me to round to the nearest degree, which means I'm going to round down to 36 degrees. That's my angle A. Okay, number 12. We've got 3 more. Find the value of each variable. This is going to be a struggle for some of you because only about a third of you watched the video on how to do these things. So this is a special triangle. It's special because I have 2 45-degree angles, and this is a 90-degree angle. And in a 45, 45, 90, we call this the small side. This side is also the same length as this one. And the hypotenuse, to find the hypotenuse, we just take the small side and multiply it by the square root of 2. So when I look at this picture, 9 is my small side, which means x is also 9. So that part's easy. X is also 9, and y is just the small side multiplied by the square root of 2. And if I look at how it wants my answers, it wants an exact answer using radicals. That means this is your answer, 9 square root 2. It doesn't want you to put a decimal. It wants an exact answer using radicals. Okay, number 13, another special triangle. In this case, if this is my triangle, we'll call this our 90. This is a 30, 60, 90. So if this is 30 degrees and this is 60 degrees, I still call this one my short side because it's the shortest side. To go from the short side to the long side, all I have to do is take my short side and multiply it by the square root of 3, and I can figure out this length. To figure out the hypotenuse, I take the short side and I double it. That's all I have to do. So looking at this picture, my short side is right here, is the y. My hypotenuse is down here. And the 12 root 3, that's my long side. That's this one right here. Well, to go from my long side to my short side, all I have to do is get rid of this part, the square root 3. Because to go from the short to the long side is equal to the short side times the square root 3. So that means that the short side equals the long side divided by square root 3. So 12 root 3 divided by square root 3, those divide each other away, and all I'm left with is a nice 12 for my short side right here. So my y value is 12, and to go from the y to the h is really easy because I just times it by 2. Again, this is you're going to struggle on this one a little bit, especially if you haven't watched the special triangle video, and especially if you have not done that homework, which unfortunately is a big number of you guys. So try this problem out, do a couple examples. Even if you get it right, maybe try a few similar problems. Down here at the bottom, when you put in your answer, it'll ask you for if you want to do a similar problem. Say yes, you do. Try it again on your own. Make sure you understand how to do it. And number 14, use a calculator to find the value of this expression, but it wants you to round to 4 decimal places. So sine of 38 degrees. When I hit enter, 0.615661, it wants me to round 4 decimal places. So here's 1 decimal, here's 2, here's 3, here's the 4th. So this is where I'm going to round to. So looking at the number after it is a 6. That means that I round up. I'm going to take this value and round it up to a 7. So my answer is going to be 0.6157. Unfortunately, I think this one's going to get missed a lot on the test, and not because sine of 38 is difficult, but you're not going to earn partial credit if you do not round correctly. So make sure that you can round the way that it wants you to round, because really that's the only math you have to do on this problem. Okay, so try these problems on your own. I also want you to go to the review. It's called Review 6 because it's for test number 6. Do the best that you can. Problems that you struggle with, come and see me. Use the Get Help button if you need to. Use the notes from here. Remember, you can use 1 page of notes on the test. So it would be a good idea as you go through the review to take some notes on what you need help with. Other than that, good luck. We'll see you on test day.